Welcome back, guys. This is the third part in the logic block series for the NXT Programming tutorial series. So welcome back. Let's get right into it. So you know that we, as you know probably last time, we covered the loop, but I didn't exactly tell you what all these options were. They'll open. Okay, there we go. I didn't tell you what all these options were because I wanted you to figure out that on your own, but if you guys didn't figure it out, well, here it is. So you notice how in the wait block we have a wait until. So basically the program will go over here and it'll wait until something is true. So let's assume that we had our infrared sensor and we'll go compare and we'll also go proximity. So basically what's going to happen, we have our infrared sensor here with us, and we're going to wait until that some obstacle is less than, the distance between the infrared sensor and the obstacle is less than 50. So basically if I was here, if 50 was here, let's assume 50 was exactly where my mic is. If I was here, nothing would happen. The program will be waiting on that block. But as I move my hand and I move my hand over here in front of it, then the program would then start executing the loop. So similarly, if we had the loop over here, let's go over here. So what I'm going to be doing, let's change this. So we're going to be using the infrared sensor. We're also going to be using proximity. And so it's the same deal here. Essentially what's going to happen, whatever's in that loop is going to keep looping until the distance between the infrared sensor and an obstacle, again 50 is my microphone, the loop will then stop or terminate in programming language terms. So what do you guys think would happen here? Go ahead and pause the video. Okay, so I've assumed that you've had a chance to think about this. What's going to happen is the robot's going to move forward in short bursts because remember, it's one rotation. It's actually not set to coast, so it's not going to be short bursts. Well, it is, but it's not going to continue moving after that because as you can see over here, the move block is not set to coast. So please do remember that. So it's not going to go one rotation and then let it go any further. It's going to go one rotation and stop instantly. So that's what's going to happen infinitely if there's no obstacle in front of the infrared sensor or ultrasonic sensor for NXT 2.0 folks. However, if there is an obstacle, then that loop will then be terminated. So the robot is not any longer going to continue moving forward infinitely for one rotation, and instead it's going to move over to this thing. And this looks massive, right? It looks massive and complicated, but it's actually relatively simple. So what we see here, it's called a switch block, as you can see in the tooltip. And also, guys, make sure to keep your ports for your sensors always selected to the port that matches up. So if I were to execute this code, it wouldn't work because my ultrasonic or infrared sensor is hooked up to port 2. So always make sure that your port is right or else your code is not going to work. Anyways, moving back to the switch. So let's go ahead and delete our loop. So the switch block is very interesting, and what it does, it can be used for a range of things. Actually, I'm going to explain something that's a little more complicated next time called blind following. That'll actually be our final tutorial in the series. So you guys actually have all of these options, but the only two that we're going to use is color sensor and infrared sensor for this tutorial series. So for the color sensor, let's go infrared sensor again, and we're gonna go and compare the proximity between the infrared sensor and something else, just because it's easier to explain this. So let's assume that I wanted if an obstacle was within 50 units of the infrared sensor, then I wanted the robot to perform one action. But if there was nothing here and between the microphone, then I don't want the robot to do anything. I just want it to be there and sit idle. So if you guys can think to real life, essentially what that would mean is, let's say these paper towel dispensers. Sorry, can't speak today. Paper towel dispensers that you guys see, it's using an infrared sensor. But let's assume that when the paper towel dispenser is idle, as in there's no one actually using the paper towel dispenser, you want it to clean itself. Let's say there's some motor in there that's cleaning the paper towel dispenser. So let's go back to the loop and think about this a bit more literally. So in order to detect a hand, what we're going to do, we're going to detect if the hand is less than or equal to 50. Okay, let's assume that that's the distance for the detecting a hand. So if there is a hand indicated by this check mark, right? So what do we want it to do? Let's say that we have the media motor hooked up to this gigantic roll of paper towels that we want to dispense. So if there is a hand there, then what we're going to do, we're actually just going to make it on. And so why, okay, I had said previously in the tutorial series that we're going to discuss, why would we want to use an on block. So basically an on block essentially moves the motor infinitely unless some other external power is making the motor explicitly stop at this set power. So basically what that means in simple terms is we're comparing and checking as to whether there's a hand, and if there's a hand, then the motor's going to keep moving. The motor's going to keep moving and continue dispensing paper towels, which actually seems smart to me now that I think about it. I mean, why do these guys only give you a set amount of paper, right? If you want more paper. But I guess it's just to conserve energy and save the planet. Go green. But let's assume that you did want to do that and you wanted to create a paper towel dispenser like that. Then the media motor would continue rotating until the hand is out of range of the infrared sensor. So that's essentially what the on block means. Now, if you were actually going to put this on block in front of the switch, what do you guys think would happen? Go ahead and pause the video and discuss. So if you guys guessed that the switch, whatever is in the switch, would never be executed, then you're right. Basically, the media motor would just continue moving and would never allow for the next block to be executed, because this is going to be executed forever and for infinity, basically, because that's how the on block works. But let's go ahead and move this back into the switch. Another way to think about the switch, if you guys are not really getting what I'm saying, is like a light switch, right? So you have a simple light switch. I don't have anything on me right now. Okay, let's use, oh, actually I do, okay. So I have this lamp on my desk right here. Let's move this over here into view. So on this lamp I have a switch, right? So this is just some sort of heater thing. I have a switch that rolls. So it clicks once, which indicates that it's on. So the on would then correspond to the check mark in the switch block. Now if I click it again, then this corresponds to the X. So it's basically just the program is taking a different path each time. So if it's on, so basically some chip in here is detecting that the motor or the switch is on, then instead of going the X path, then we're going to go the check mark path saying that yes, it is on. So we're just checking for some certain condition before the switch. So so if it is on, then we're going to go take this path and we're going to execute whatever's there, and we're just going to keep moving onwards. But if it isn't on, then we're not going to do that. So let's say that you wanted the switch to execute permanently, and let's actually just finish off this switch. Let's say a media motor is hooked to some cleaning apparatus for the our magical paper towel dispenser, and you want this to also be on. So essentially what's going to happen is the switch right here is only going to be executed once, right? So what does that mean for the paper towel dispenser? Go ahead and pause and discuss. So if you guys guessed that only one motor would move infinitely, then you're right, because this would merely just execute the media motor to move infinitely and nothing else would happen, because it's not again going to check as to whether there's something in the if there's something in front of the infrared sensor. So basically what we need to do, if you guys guess that we need to put this in a loop to be executed multiple times and infinitely even, then you guys guessed right. Mind blown, right? Now we have a loop or switch within a loop. So basically we're talking fancy logic at this point. So let me explain to you guys what's happening here, because this is slightly complicated. So we have an infinite loop. So this means that as soon as we click the start button, then what's going to happen is the loop is going to execute everything that's within it infinite times. So we're going to constantly be checking as to whether there's a hand in front of the infrared sensor or not. And if there is, then we're going to move the media motor, and if there's not, then we're going to move the large D motor. Does that make sense to everybody? If not, then go ahead and email me. I'll provide my email in the description below, and I can help you guys out on that. I can provide you guys some extra links even if you guys want me to. But this is going to get us really, really well on the way to line following, which is what I'm going to be teaching you guys next. Alright? So see you in that tutorial.